बाइनरी स्टार्स क्या होते हैं? दो बहुत बड़े से हैवी स्टार्स अपने में एक दूसरे की ग्रेविटी, so now because they are stars, they both have very heavy mass, so center of mass will be somewhere in between. It will be closer to the smaller one, but it will not be just inside. Earth और sun के केस में, because Earth का mass sun की comparison में बहुत कम है, so that is why we assume that center of mass is exactly at the inside of sun. Sun बन जाता है center. But here both of these planets revolve about their common center of mass with same angular velocity. ओमेगा दोनों के लिए सेम है. m1 की रेडियस r1, m2 की रेडियस r2. सेंट्रीपिटल फोर्स रिक्वायर्ड फॉर ईच m r ओमेगा स्क्वायर पहले को चाहिए, m r ओमेगा स्क्वायर दूसरे को चाहिए, and that will be equal to g m1 m2 by r square. R1 and R2 are the distance of this center of mass. तो सेंटर ऑफ मास के फॉर्मूले से R1 हो जाएगा m2 डिवाइडेड बाई m1 प्लस m2 इंटू r, और R2 हो जाएगा m1 डिवाइडेड बाई m1 प्लस m2 टाइम्स r. सेंटर ऑफ मास हमेशा इनवर्सली प्रोपोर्शनल होता है मास के. जो मास ज्यादा होगा उसके लिए डिस्टेंस कम होगी. so if m is greater, r will be less. That's why mass is inversely proportional to r. Right? Okay. Now in this case, इसी जगह पे वैल्यू पुट कर दो कि अगर R1 की m1, R1 is m2 divided by m1 plus m2 times r omega square is equal to g m1 m2 upon r. From here we get the omega. Omega से time period मिल जाएगा, time period of rotation. m1 m2 gone. Omega square is g m1 plus m2 divided by r cube. ये किसका फॉर्मूला था? mr ओमेगा स्क्वायर, सेंट्रीपिटल फोर्स का. सेंट्रीपिटल फोर्स का फॉर्मूला होता है mv स्क्वायर बाय r. v को r ओमेगा पुट करोगे तो mr ओमेगा स्क्वायर. दोनों स्टार्स को, दिस वाज अ क्वेश्चन आस्क्ड इन नीट. A binary star system consists of two stars. One star has twice the mass of other. The star rotates about their common center of mass. Which of the following statement is correct? Star having the smaller mass has twice the angular momentum. Okay. Both stars have same angular momentum. Both stars have same linear speed. Both stars have same kinetic energies. Obviously, they will not have same kinetic energy. They will not have same angular momentum. Because omega the same है, it will be m into r square. Now we'll substitute the value to find angular momentum. Angular momentum का formula होता है I into omega, and I is equal to mr square. I will be equal to m into r square. So accordingly, we will find out. दोनों के लिए सेम क्या है? They both have same angular velocity and they both have same time period of rotation. They rotate about their common center of mass with same angular velocity. Same angular velocity about their common center of mass. Right? So common center of mass के about they have same angular velocity. इससे हम टाइम पीरियड निकालेंगे फॉर एनी बाइनरी स्टार सिस्टम. इसके वेलोसिटी एंड एनर्जी रिक्वायर्ड टू launch a satellite जितनी सैटेलाइट के पास एनर्जी है उसका फॉर्मूला क्या था, -G/m/2r। सपोज अगर हमें किसी सैटेलाइट को इतनी एनर्जी देनी है कि उसकी ऑर्बिट करेक्ट करनी है, वो सैटेलाइट पहले किसी दूसरे ऑर्बिट में आ गया r1 में, and it is supposed to be in a space in a orbit of r2, then what is the minimum energy required to be given? What is the minimum energy required to be given so that the satellite changes its path or orbit from r1 to r2? The energy required to change the orbit will be equal to final energy minus initial energy. Final energy will become minus G capital M by 2r2, or initial energy is minus G capital M by 2 times r1. Escape velocity from a planet and escape velocity for a satellite. तो इनमें क्या रिलेशन होता है? So when a satellite is closer to Earth, there are two type of satellite: geostationary satellite and polar satellite. Geostationary satellite, the one which appears at rest, इसका मतलब उसकी speed of rotation अर्थ के जितनी होगी, और इसलिए time period will also be exactly same as time taken by Earth. Time period is 24 hours. तो यहाँ से इसकी हाइट निकालते हैं, कुछ 36,000 की आती है, 36,000 किलोमीटर फ्रॉम दी अर्थ. दैट विल बी दी जियोस्टेशनरी सैटेलाइट हाइट, 35970 किलोमीटर. So at this height, yes, at this height, any satellite revolving will have same time period as that of Earth. It will appear at rest. It is used for the communication. The satellite orbit speed is root of gm by r if we are near the Earth's surface. जो अर्थ के सरफेस के आसपास होते हैं उनको हम बोलते हैं पोलर सैटेलाइट, which is used for the GPS and all. For a polar satellite, orbital speed is root gm by r. इसका टाइम पीरियड निकालोगे तो ये बहुत कम आता है, जैसे सम 1.1 hour, 2 pi under root of r cube by gm, which is 2 pi root r by g. 2 pi root r by g. So orbital speed is root gm by r and escape speed is root 2 gm by r. So that become root 2 times orbital speed. यानी अगर उसकी ऑर्बिटल स्पीड में कुछ 41.4% का इंक्रीज हो जाए, then that satellite will escape. The satellite which is in its orbit, if the speed given increases by 0.414 or 41.4%, then that satellite will be gone to infinity. ठीक है, तो जब हम किसी पार्टिकल सैटेलाइट को लॉन्च करते हैं, एट द टाइम ऑफ रिलीज व्हाट इज द स्पीड गिवन, at the launch, at the time it is projected from the nose part of the rocket, that decides where it will go. If suppose the speed given is same as escape speed, then particle goes to infinity. Then it goes to infinity. अगर escape speed से ज़्यादा speed मिल जाती है तो if for a satellite speed become greater than escape speed. Escape speed तक speed escape speed के speed provide करने पे the particle goes to infinity. अगर उससे ज़्यादा देंगे तो वो कहाँ जाता है? Then it goes to the intrinsic space. What is that intrinsic space? Interstellar space. It goes to interstellar space. Interstellar का होता है जहाँ पे gravity नहीं होती. The position where gravity does not. So if the speed given is greater than escape speed, it goes to interstellar space. और वहां पर उसके पास जो एनर्जी बचेगी, the energy required to overcome the gravitation, that is half into VE square. VI is velocity in interstellar space. It will become root of V square minus VE square. Speed in interstellar. Interstellar space is the space where gravity does not exist. And why it does not exist? Because it might be between two very massive black hole or maybe very massive galaxies. So that their gravity nullifies each other. So now it is completely done. All the questions from the gravitation. The many of the formulas are exactly similar to electric field. So electric field के formulas से हम उसको calculate कर सकते हैं. Next आते हैं properties of bulk matter. Solids, liquids. This is the next chapter. So solid are those materials जिनमें force लगाने पे कुछ change नहीं होता. If it is not changing at all, then that is called rigid. Non-rigid those which get deformed on applying the force. Non-rigid are further classified. Non-rigid are further classified as elastic and inelastic. Elastic material जिनमें force लगाने पे, elastic material जिनमें force लगाने पे deformation तो होता है. Solid, rigid and non-rigid. Rigid जिनमें force लगाने पे कोई भी change नहीं होगा. There is no elongation, no compression or something. Non-rigid are those in which when we apply force it gets deformed, but on removing the force, if it comes back, that is called elastic. If it doesn't come back, it get permanently deformed, then that is called plastic body. Elastic, those which gets deformed on applying force, but on removing the force, it comes back. Yeah. So for any elastic material, to check its strength, there's a concept stress. Stress checks the strength of any material, and that is the force per unit area. अब ये force कौन सा वाला है? ये वो force नहीं जो हमने लगाया. Elastic material में just like a rod, when we are applying the force on the rod, this F is the force that we have applied as external force. As a result, the molecules will be stretched and those molecules will try in opposite direction to restore the original length. That is called property of elasticity. If you apply force and the body gets deformed very easily, it is not coming back to the same initial position, then that is called plastic body. If on applying force, it is opposing the deformation, and as soon as the force is removed, it goes back to the initial shape. That is called perfectly elastic body, and by that logic, perfectly rigid are also perfectly elastic. Perfectly rigid are also perfectly elastic. Why? Because when we exert force, there is no deformation. So on applying force as well as on removing force, it remains the same shape. So all perfectly rigid bodies are also perfectly elastic bodies. Perfectly rigid material प्रैक्टिकली कुछ भी बट अगर यूज close to the ideally rigid body. Perfectly rigid or also perfectly elastic because when we apply force, due to that force, when we apply force, due to that force is deformation, but on removing the force, the bodies come back to the original shape. Force लगाने पे एक opposition होता है, that opposing force is called restoring force, which is the cause of elasticity of material. So ये जो force है, this is actually restoring force. The stress is only when there is a restoring force developed in that material per unit area. Strain, because of that force, there will be some deformation. Like in this case, it is the deformation in the length. So change in that dimension divided by initial dimension, that ratio is defined as strain. So when any force is applied on a body, there will be some kind of change if it is not a perfectly rigid body, there will be some deformation, and that deformation will be represented as a fractional change called as strain. Stress by strain is constant according to Hooke's law. Stress is directly proportional to strain, and the ratio of stress to strain is called Young's modulus or modulus of elasticity. There are three possible situations. So there are three possible type of stress. There are three possible situations. क्या होती हैं? 1D, 2D, and 3D. There are three possible ways in which this stress has been applied. The stress by strain is constant according to Hooke's law, and that constant is called modulus of elasticity. Depending upon the nature of stress and strain produced, there are three types of moduli of elasticity. First, Young's modulus. So Young's modulus के लिए there is a normal stress and the longitudinal stress. First situation is Young's modulus. Young's modulus is when the force is applied perpendicular to the area. Young's modulus is when a force is applied perpendicularly. It is called as normal stress. Force is acting perpendicularly, so there is a normal stress. Also called as tensile stress. जब बाहर की तरफ force लग रहा होगा, F perpendicular by area. जब अंदर की तरफ लग रहा होगा, then it is called compressive stress. Initial length is L, and due to this force, there is a small elongation called as delta. The strain produced is called longitudinal strain. The ratio of stress to strain is called Young's modulus. So in this case, the modulus of elasticity is stress by strain. F into L divided by A times theta. Young's modulus is the constant for a material. So अगर हम force निकालते हैं यहाँ से आ जाएगा AY by L times delta L. This is the force required to change the length of a rod by delta L. F is equal to K times delta L, and it is the force is exactly similar to the spring force because spring force में F is equal to K into X. जितना elongation होगा, the force produced will be directly proportional to it because spring में भी it is a elastic force or elastic nature of this spring. and equivalent amount of spring constant is by L. So when there is a rod and which is stretched, that stretched rod is called, that stretched rod is behaving like a spring, and its equivalent spring constant is by L. जितने भी फॉर्मूले हमने स्प्रिंग के लिए पढ़े हैं वो सारे फॉर्मूले हम यहाँ भी यूज कर सकते हैं. इक्विवेलेंट स्प्रिंग कांस्टेंट इज K. Force required to change the length by delta L, and similarly change in length of a rod when we apply a force F. When we apply a force F, change in length का फॉर्मूला आ जाएगा F into L divided by A times Y. अगर हमने किसी वायर पे या रॉड पे when we apply force F perpendicular to a cross section area A and length is L. Right? So on applying the force, the final length of the rod will become L plus delta L, and that will be L common 1 plus F by A times 1. Energy stored in the rod when we apply force, and for the rod is opposing it. Because of that opposing force, there will be a elastic potential energy stored. रॉड में because of that elastic force, जैसे spring में होता है, when we pull it, there is a force in opposite direction which opposes. Elastic potential energy stored will be equal to half K into delta L square. Half A by L into delta L square. But since there is a material, so हम इसमें use करते हैं elastic potential energy density. Elastic potential energy density of what? Elastic potential energy density of a material होगी, किसी rod के लिए नहीं होगा because it is defined for a unit volume. Energy stored per unit volume is energy density, so that will become half y into delta L by L square. Delta L by L is strain, so half Young's modulus into strain square. Potential energy density is energy stored in a unit length, unit volume of the rod, so it becomes half into Young's modulus into strain square. Young's modulus is stress by strain, so that become half into stress into strain, or we can write half strain square upon Young's modulus. F1, the length of the rod is L1. When we apply force F2, the length is L2. When force F1 is applied, length is L1. When force F2 is applied, length is L2. Calculate the original length.
So shouldn't that be stress square upon
हाँ बेटा.
जो formula है, shouldn't it be stress
Yeah,
square?
yeah. Thank you. Strain को हम लिखेंगे stress by Young's modulus. It will be half of stress square by Young's modulus. The question is, when a force F1 is applied, length is L1. When force F2 is applied, L2. Calculate the original length of the wire L in terms of F1, L1 and F2, L2. So we will apply that formula. Change in length is FL upon AY. If the original length is L and final length is L1, the change in length is L1 minus L. That become F1 L by AY, and change in length when force F2 is applied is F2 into L by AY. Divide the two equation. Divide the two equation to find the value of L. कितना आएगा सॉल्व करने पे? The value of L. Right, so divide on both the sides and you get the value of L as F1 L2 minus F2 L1 divided by. Okay, so when you divide these two, L1 minus L divided by L2 minus L, this will become F1 by F2. Right. Next concept is so another is like suppose if we have two rod combination, तो हम उसको use करेंगे exactly similar to the two spring combination. So when rods are connected in series and we apply force F, so हम दोनों के लिए उसकी equivalent spring constant calculate कर लेंगे K1, K2 by using their Young's modulus and their length. Area has to be same. Area has to be same for the practical purpose. Only then they will be connected. So if we have to calculate the overall elongation in this composite rod, then we calculate the K equivalent and F is equal to K equivalent times delta L. So जैसे हम series में spring के लिए करते हैं, 1 upon K equivalent is 1 upon K1 plus 1 upon K2. Likewise, we'll find out here the K equivalent value of this series combination of the rod. Right? Okay. Similarly, if it is connected, so इसमें एक y equivalent भी आता है calculate करने के लिए. K1 को हम लिख लेंगे a y1 by L1. K2 will be a y2 by L2. But when you calculate K equivalent, area is same. Young's modulus is y equivalent, but the length become L1 plus L2. So we can substitute here in the K equivalent to calculate the equivalent Young's modulus. Right, so we can find out the equivalent Young's modulus by this combination. This is in series. अगर दोनों का अलग अलग निकालना हो, what is the elongation in each rod? So this is delta L2 and here it is delta L1. सीरीज में कनेक्ट करने पे फोर्स सेम होना चाहिए, so K1 delta L1 should be equal to K2 delta L2, and which is also equal to the force applied. So we can also calculate the separate elongation in each rod. Likewise, when they are connected in parallel, they must have same length. They must have same length. Area might be different. Suppose there are two rods of different area and they are connected together, maybe welded together, and the force F is applied. ऊपर वाले का एरिया A1, नीचे वाले का एरिया A2. लेंथ दोनों की सेम होनी चाहिए फॉर द प्रैक्टिकल अरेंजमेंट. ऊपर वाले की Y1, नीचे वाले की Y2. By the equivalent spring constant, we can assume this as the combination of two parallel spring, और parallel spring के लिए equivalent constant होता है K1 plus K2. So F is equal to K equivalent into delta L, that we can calculate from this. और दोनों को मिलाकर हम एक रॉड एज्यूम कर लेंगे तो उसका एरिया हो जाएगा A1 plus A2 into Y equivalent by L. पहले वाले के लिए A1 Y1 by L, दूसरे वाले के लिए A2 Y2 by L. So from here we can calculate equivalent Young's modulus of the composite rod. Next is, बेटा समझ आ रहा है ना क्या क्या कर रहे हैं हम? This is a combination of two rods, series and parallel. So all the cases are exactly similar to that of spring. उसको equivalent spring में convert करके spring के formula use करके we can find out the energy stored, we can find out the elongation. Right. Next is elongation a rod due to its own weight. ये भी क्वेश्चन आया हुआ है एग्जाम में. There are two wires. ठीक है, मतलब इस पे equivalent spring equivalent Young's modulus पे there many questions have been asked. Second is next is elongation in a rod due to its own weight. तो ये बहुत छोटे टॉपिक है लेकिन इनके एक आधे क्वेश्चन आते हैं, which is very very easy. Mostly it is just the formula based. Elongation in a rod. अभी तक सारी रॉड को हम massless assume कर रहे थे. The elongation was only due to the external force applied. If suppose it is held vertically, a rod is hanging vertically, length is L, mass is M, then that means it has a force acting around different part, different forces acting. So this one integrate करना चाहिए, but as a shortcut we can assume because mg will be acting on its center. Mg will be acting at the center of gravity or center of mass. So we can assume that the effective length of this string is, this rod is not L, it is L by 2. The effective rod length is L by 2. So we can apply that formula of elongation delta L is FL divided by AY. F is equal to mg, length is equal to L by 2 divided by A times Y. This is elongation of rod due to its own weight. mgl by 2ay. This is the elongation rod due to its own weight. Now because of this elongation there will be some work done, and because of that work done it will have some potential energy or energy stored. Elastic energy is stored due to its own weight. तो आता है m square g square L by 6 times ay. राइट, ये कैसे किया हमने इलास्टिक पोटेंशियल एनर्जी? इसके लिए तरीका है इंटीग्रेट करने वाला, बिकॉज अदरवाइज वी कैन नॉट डायरेक्टली यूज, वी कैन नॉट डायरेक्टली कैलकुलेट लाइक दैट। हाउ? सो इसमें हम एक छोटी सी लेंथ लेंगे, द स्मॉल लेंथ ऑफ द रॉड एज डी एक्स, और नीचे से x डिस्टेंस पे, फ्रॉम द बॉटम x डिस्टेंस वी कंसीडर अ रॉड ऑफ लेंथ dx। इस dx पे जो फोर्स लग रहा है उसकी वजह से इलोंगेशन होगा, एंड दैट इलोंगेशन इज dy। अप्लाई दिस फॉर्मूला, इस dx लेंथ की रॉड में जो इलोंगेशन है, दैट इलोंगेशन इज dy। सो dy इज इक्वल टू फोर्स नीचे वाले का मास, द फोर्स व्हिच इज पुलिंग दिस इज द वेट ऑफ द रॉड हैंगिंग बिलो दैट पॉइंट। उसके नीचे का जो मास है दैट इज m/l into x into लेंथ, इसके लिए हमने dx। वी हैव टू कंसीडर अ वेरी थिन रॉड, पूरे रॉड को छोड़ के हमने एक dx लेंथ की रॉड ले ली, फ्रॉम एट अ डिस्टेंस ऑफ x फ्रॉम द फ्री एंड, एट अ डिस्टेंस x फ्रॉम द फ्री एंड, डिवाइडेड बाय a times y। ये तो हो गया इलोंगेशन के लिए, जो हमने पीछे इलोंगेशन कैलकुलेट किया है उसका एक्चुअल तरीका यहाँ से है, mg/a/l x dx। इंटीग्रेट करोगे 0 to डेल्टा एल, तो यहाँ 0 to l, ये आ जाएगा mg/l/2ay। नाउ व्हेन वी हैव टू कैलकुलेट द एनर्जी स्टोर्ड, तो इस छोटी सी रॉड में पोटेंशियल एनर्जी स्टोर्ड इन दिस रॉड ऑफ लेंथ dx। तो डायरेक्ट फॉर्मूला से भी काम चल जाएगा, लेकिन क्वेश्चन में कभी कभी the mass is not uniform, तो हम इसका मास फोर्स को अकॉर्डिंगली चेंज करके एंड देन वी विल डू द इंटीग्रेशन। सो एनर्जी स्टोर्ड का फॉर्मूला आएगा एनर्जी डेंसिटी इनटू वॉल्यूम, एंड वॉल्यूम इज एरिया इनटू लेंथ। एनर्जी डेंसिटी का फॉर्मूला, वन ऑफ द फॉर्मूला वाज हाफ स्ट्रेस स्क्वायर डिवाइड बाय यंग्स मॉडुलस a into dx। स्ट्रेस कितना होगा? फोर्स अपॉन एरिया। फोर्स इज फोर्स जो इस पे नीचे की तरफ लग रहा है जिसकी वजह से ये पोर्शन इलोंगेट हो रहा है, that is the weight of the portion hanging below this। Substitute that stress, so stress will be force upon area, that is mg by al times x। So du will be equal to half mgx by al whole square divided by Young's modulus into adx। It become m square g square divided by a square से cancel हो जाएगा, l square y 2 integration of x square dx। u will be equal to m square g square divided by 2ay l square into l cube by 3। so डायरेक्ट आपको फॉर्मूला तो याद होना ही चाहिए, but you should also know how to derive it, because in questions the mass density is given non-uniform and then also it can be asked, right? So this is for the shear modulus, sorry, this is for the Young's modulus, the first case when force is applied along the length, when force is applied along the length, then energy, then elongation delta L will be because of Young's modulus। Second बढ़ते हैं आगे, second possible type of stress or Young's second type of modulus is called shear modulus, when a tangential force is applied। Shear modulus is also called as modulus of rigidity। जब भी हम किसी रिजिडिटी को ईटा से डिनोट करते हैं, शेयर मॉडुलस को ऐसे डिनोट करते हैं, इन एनी बॉडी व्हेन द फोर्स इज अप्लाइड ऑन अ सरफेस। पहला वाला था 1D लेंथ के अलोंग, रॉड के अलोंग, सेकंड वाले केस में इट इज अलोंग द सरफेस, सो वी अप्लाइड हम टेंजेंशियल फोर्स। because of that tangential force. नीचे वाले को fix रखते हैं. So that is again one of the information. हमें force या तो दोनों end पे लगाना होगा या फिर one end has to be fixed to a certain point. The lower face is fixed. The lower face is fixed on the ground, and the upper surface a tangential force is applied. This tangential force is on an area tangential direction, so it is also called as tangential stress, or it is called shear stress. Shear stress is that tangential force divided by area on which it is applied. A is that topmost area. So since the lower surface is fixed, it is slightly displaced from its initial position, and that displacement causes the deformation. It goes slightly displaced by x. So shear strain is defined as relative displacement divided by perpendicular distance, which is denoted as theta also, or tan theta, because theta is very, very small. So shear modulus or modulus of rigidity is the tangential stress divided by shear strain, that is x by L. It will be equal to theta only and only when theta is in radian. So eta will be equal to ft divided by a into theta when theta is in radian. The tangential force required is eta a into x by L, or it will be eta a into theta. This causes deformation, the shape of the body. Right, so this is shear modulus. Similarly, third one is bulk modulus. Bulk modulus is for the volume when the force is applied throughout the volume. Bulk modulus is on the three dimension. So three dimension body पे force लगाने के लिए the easier method is it is kept inside a liquid, और हम liquid पे pressure exert करते हैं. Otherwise mechanically it is not feasible to apply force from all the directions simultaneously. So when we exert pressure on this liquid, because of that increase in pressure, the volume gets compressed from V. It changes to V minus delta V. Increase in pressure is force upon area, so that will be the bulk. Increase in pressure is delta V, which is also called as hydraulic stress or the volume stress. And volume strain, so since on increasing the pressure volume always decreases, it will be minus delta V by V. The bulk modulus is increase in pressure divided by minus of delta V by V. So minus V times delta V by delta V. This is the bulk modulus will always be positive. The minus sign is because volume always gets compressed. For any gas, it will be written as minus V into dP by dV, because for gases, pressure volume relation will be different for different process. So here bulk modulus means more bulk modulus, it will be difficult to compress or difficult to change the volume. Inverse of bulk modulus is called compressibility, that how easily a body can compress, can get changed, easily be compressed by applying the pressure. Compressibility K, or sometimes noted as C, this represent how easily a body can be compressed by applying the force. It will be 1 upon bulk modulus. Right? ठीक है, we will continue next class, which will be on Monday. Weekend is not possible. I tried last time. Weekend is possible very late. So think. Right, compressibility. So there are these three: bulk modulus, Young's modulus, shear modulus, bulk modulus, और चौथा क्या होता है? Poisson's ratio. Poisson's ratio is the ratio of lateral strain to longitudinal strain. जब भी हम किसी body को elongate करते हैं, length gets stretched, but the radius gets slightly compressed.
माइनस हाफ
L to L plus delta L. हाँ बेटा?
माइनस हाफ से हाफ तक होता है थ्योरेटिकल वैल्यू।
आवाज नहीं आ रही, फिर से बोलो।
सर थ्योरेटिकल वैल्यू इसकी माइनस हाफ से प्लस हाफ होती है।
हाँ बेटा, थ्योरेटिकल वैल्यू इसकी माइनस हाफ से प्लस हाफ होती है और प्रैक्टिकल वैल्यू 0 से हाफ होती है। लेटरल स्ट्रेन टू लॉन्गिट्यूडनल स्ट्रेन, क्योंकि प्रैक्टिकली ये पॉसिबल नहीं है हम लेंथ इंक्रीज करें और रेडियस चेंज ना हो, सिंस द टोटल मटेरियल इज फिक्स्ड, टोटल वॉल्यूम इज फिक्स्ड. So that is why it will always have some perpendicular deformation, delta r by r divided by delta l by l. This is a constant that will relate Young's modulus, क्योंकि लेंथ के along था, shear modulus सरफेस के along था, दोनों परपेंडिकुलर में चेंज होंगे. ठीक है, चलो we'll continue next class then. We have almost covered this chapter. Solid वाला part, एक ग्राफ बचा है सिर्फ, बस इसमें फॉर्मूला बेस्ड क्वेश्चन है, आप उनको ट्राई कर लेना. We'll continue on Monday. Thank you. I'll share this note.